Here is the next example. In this example also we are doing the DC analysis. So here this transistor is NPN transistor. How do I know? This arrow is going out of the transistor and the arrow is always on the emitter side. Okay, so here assume that the transistor, to do the DC analysis we have to start with assuming the transistor is in active mode of operation. So I'm going to assume this transistor is in active mode of operation. When it is active mode of operation, this VBE equal to 0.7 volt. Now if since VE equal to 0 volt, it's directly grounded, what is the VB? VB must be 0.7 volt. Based on this I can find IB must be 5 minus 0.7 over 10k. That will give us the IB. So IB equal to, I end up finding that value as 0.43 milliampere. Remember, IB current is really small. Probably it's going to be in microamperes. But here I see 0.43 milliampere. And definitely I feel like that's a big number. But we will see what it's going to lead to. So if IB is 0.43 milliampere, I can find IC based on the beta equal to IC over IB. So IC must be beta times IB. You need to remember this formula, IC over IB. Now beta times IB is nothing but 100 times 0.43, so that's 43 milliampere. That's a huge amount of current. Now IE must be based on this IC plus IB. Okay, it's going to be 43 milli plus 0.43, so it's going to be 43.43 milliampere. Okay, now based on this I can find the VC value. VC must be, so I know this current is IC, so VC must be 10 minus VC equal to 2k times IC. So VC must be 10 minus 2k times what is IC? We end up with 43 milliampere. So it's a negative number. So it must be 86 minus 10, so minus 76 volts. And VCE equal to VC minus VE minus 76 minus 0. So it says, which is minus 76 volt, which is less than 0.3 volt. Okay. So I told you we need to verify. Since we started solving this example by assuming this transistor is in active mode of operation. Now we need to verify by seeing the VCE value. We found that VCE is less than 0.3 volts. So definitely this is not in active mode of operation. Okay, so this must be either in saturation mode or cutoff mode. And to be cutoff mode, if it is cutoff mode, open switch and you have VB as 5 volts, since there won't be any current. I'm talking about cutoff mode, and this is 0 and VC 10 volts. So if you have VC VB voltages and assuming in cutoff mode, which is not possible. So what I'm going to do, I'm going to take this transistor is acting in a saturation mode of operation. When it is in saturation mode, we always assume saturation means both transistors are going to be in forward, both junctions are going to be in forward biased, both junctions in the NPN transistor. So in that case, I'm going to take, if it is in saturation mode, take this VCE equal to 0.2 volt always. That VCE equal to 0.2 volts. Now ignore this beta value. This beta value is no longer valid. The beta is valid only when it is in active mode of operation. Now we found that this is not an active mode of operation. We have to solve the circuit by taking VCE equal to 0.2 volts. So when we are solving it in saturation mode, IB is not going to change because this transistor, this junction is always forward biased, either in active mode of operation or saturation mode of operation. So that must be 0.7 volt. So VB must be 0.7 there. IB must be same. IB won't be any difference. Now IC and IE, those are not valid anymore, so I'm going to rewrite the equation. So the equation I'm going to rewrite based on this. It's going to be minus 10 plus 2k IC. Why I'm doing minus 10? I mean, it's different way of writing down the KVL equation. Some students write it as plus 10 minus 2k IC minus 0.2 and 0. But here, if it is a voltage gain, I'll take it as minus, and if it is a voltage drop, I'll take it as plus. So it's not going to make any difference. Plus so I'm minus 10 plus. So why it is minus? Here the arrow indicates that that's 10 volts. So basically this is positive terminal, that's negative terminal. So current is entering the negative terminal. I'm taking that as a negative voltage. So negative 10 plus 2k IC plus 0.2 must be equal to 0. V equal to 0 in this case. So now here I can find IC value. IC value is simply 9.8 over 2k, which is 4.9 milliampere. Now I have IC value. Even it is in the saturation mode, this formula is still valid. IE must be equal to IC plus IB. So it's going to be 4.9 plus 0.43 milliamperes. That's the total IE. V is still same because it's grounded. Okay, now we can find the beta forced. The beta force is that nothing but the beta value is going to change when it is in saturation mode. Beta forced must be, formula is same, IC over IB. Now I have IC equal to 4.9 milliampere and IB is 0.43 milliampere. So the beta forced is approximately 11.4. Beta doesn't have any unit because both of them are currents. Okay, that's about the transistor when it is acting in a saturation mode. I'll stop it here. In the next video, we'll solve an example with PNP transistor.